going to spend some time simplifying equations containing exponents to remind you that this really pays off later in math, and sometimes it's not obvious, but let's just do a couple really straightforward ones, like x to the 8th times 1 over x to the 3rd. And there's two ways you could do this. You could multiply this like this, right? Multiply fractions straight across, don't we? You can multiply that. We'd get x to the 8th over x to the 3rd. And then we could use that rule that says x to the m divided by x to the n is equal to x to the m minus n. In that case, we'd check here, make sure our bases are the same, and they are. We'd get x to the 8 minus 3 to the 8 minus 3 is equal to x to the 5th. So that's one way we could get that answer. The other way we could do it is we could look at this way and say this is x to the 8th, x to the 8th. But another way to express 1 over x to the 3rd would be x to the negative 3rd over 1. And what I did here is I just took the reciprocal of this thing, just flipped that over, and created a negative exponent there. And then we'd get, right, x to the m times x to the n is equal to x to the m plus n. So we'd have x to the 8 plus, right, plus what? Plus negative 3. So plus negative 3 is equal to x to the 5th. So two ways to get to exactly the same answer. All right? Let's try another one and see if we can. Here's one that was of some concern to me because it's really easy to get a problem like this wrong. So let's look at this. And that's this one. It's x to the 11th y to the 10th over x to the negative 3rd y to the negative 1. And here, this one is, as they say, fraught with peril. First off, the way I'm going to look at this is this. I'm going to partition this out and just look at this. Okay, this is the first problem right here. My handwriting sucks for some reason right this second. So let me rewrite this to make it more clear. This was to the negative 3rd power. So the first one I'd have x to the 11 minus, right, that's formulaic for the formula we just looked at the last page, minus, right, negative 3. So minus negative 3 is equal to x to the 14th power, isn't it? And then I would do the same thing here looking at this one. Say, okay, I have this problem right here now, and this is the same. It's y, isn't it? So y to the 10 minus, that's from the formula, but remember we have negative 1 here, so minus negative 1 is equal to y to the 11th. So the answer to the whole thing is x to the 14th, y to the 11th. So it's something you have to really think about. I'm just using those couple of rules right now, right? And those rules are the rules you have to use over and over and over again and make sure that you use the rule. Let's see if we can do just, I guess, one more to see if we can make anything of this one. Here we have x to the 4th maybe, y to the 7th, and we have this thing as a quantity to the negative 3. Now what we know is this, and this is the rule I want to use now. And hopefully you already know these rules. If you don't, I hope that you're writing them down because they're just going to help out over and over and over. So a b to the power of m is exactly the same as a to the m times b to the m, right? Which says that exponents are distributable over multiplication. So what we're going to, and there's more than one way to do this, and I can already hear people in my head telling me I would, do this differently, but okay. So this is what I'm going to do. I'm going to go ahead and distribute because this says that this is how I got this, right? So I'm going to distribute this here and here. Now what might not have been obvious was this, right? This is this other rule. This is this other rule that we have to keep in mind. There's about 6 important, really important rules. That a to the power of m, all raised to the nth power, is a to the m times n power. So when I distribute this, I get I get x to the 4 times negative 3, which is to the negative 12th, isn't it? And then y to the 7 times negative 3, which is negative 21, isn't it? Remember, this whole thing is over 1. So now, because I have these negative exponents, I need to flip this thing over and get 1 over x to the 12th, y to the 21st. Okay? So I really do hope this is helpful. You got to work on this, and you got to memorize these rules. And the rule that I just used was that a to the negative nth power is equal to 1 over a to the positive nth power. And what I'm doing is, what happened on that one was this. I'm looking at it like that. And this solidus or fraction bar is this one, and this one is this one. So what happens is, it turns out that it creates a fraction. All right? So I hope this was really helpful. And if you're not already subscribed, please do. And your comments are always welcome. Thanks.